are in listen-only mode.
Good evening and welcome to How Do I Use Docker Containers in Production with Daniel Van Gils. Just before we start, I want to give a quick introduction to eSynergy. eSynergy specialises in open source and cloud resourcing. If you're looking to build out your team or are looking for a new role, our details will be made available at the end of the session. Now, moving on to some housekeeping. If you have any questions for Daniel, please fire them over via the question box throughout, and Daniel will answer them at the end of his talk. We are recording the session, and the slides and recording will be made available at the end and sent to you in an email with my contact details. Now I'm going to pass you over to Daniel to begin the talk.
So thank you for the introduction. So good afternoon everyone, or good morning or good evening, depending where you are right now. And thank you eSynergy for having me. My name is Daniel and I'm the developer advocate at Cloud66, and today I will talk about how the hell do I run Docker in production and will it scale? So I divided the webinar into two phases. First, I will be talking about getting the right container image right, and then moving from that I'm going to phase 2 and tell you all about the things you need to reconsider running containers in production. Before I go into details, just let me talk a little bit about myself. So I'm born and raised in the Netherlands and I have a background in computer science, electronics and applied physics, and I started in programming in Java in 1995, and I'm one of the founders of the Java user group together with Sun Microsystems to promote Java throughout the Netherlands. And from the Java I also programmed in PHP and AS3, and I spent some time in Silicon Valley working for Marimba and returned back to Amsterdam, where I worked as a lead developer in interactive media industries, and I run my own digital agency for over 10 years. And before I joined Cloud66, I worked for an award-winning agency in Amsterdam. And also I like to work with open hardware, and nowadays I'm programming in Ruby, C# and Go. So let me first talk a little bit about Cloud66. So Cloud66, we are trying to simplify the DevOps. So we provide tools for developers doing operational stuff. So we build, deploy and maintain any application on any server on the cloud provider of your choice. And also we at Cloud66, we are running Docker in production for almost 1.5 years for our customers, and I counted last week, so we're running over 800 Docker stacks right now, used by over 500 customers, and I can say that you can safely run Docker in production today. So I'm really sitting between development, operations and design, so that's where the developer advocate sits in, if you look at the company. So I call myself a thinker, a creative technologist, and my role as a developer advocate at Cloud66, I really need to know everything what's going on in the company, but also in the Docker ecosystem. But at heart, I'm still a developer, and what I really like about being a developer is like looking at this bowl of fruits, all these different fruits like open source, closed source projects, libraries, all this color, size and taste. And the last couple of years I'm trying to solve this problem, how to mix match all those technologies, and 3 years ago when Docker came around I found this solution, because now I have the tools to really mix match technology. And I've really solved when I run the first Hello World example and start thinking with this new technology. But after a while I felt a little bit lost, especially how the hell do I run Docker in production and will it scale? I was really trying to figure out what kind of skills and tools we need to develop and how to run that in production. It was, to be honest, a steep learning curve. So before I really dive into how to create the right image, I just want to take a step back and tell a little bit about the learning curve if you learn like a new technology like Docker or other technology of playing an instrument, for example. So if you start learning some new technology or you want to run Docker in production, you have like on one axis you have time and the other one you have skills. And I draw this dark green line that shows you the time and the skills that you evolve over time when learning. But the funny thing is that there's also a light green line, and that's more like how you feel during the learn process of learning a new skill like Docker. But you first start with the hello world, and at that point you don't know what kind of skills you need using Docker at its full potential, like running it in production. And then you start learning and you gain a lot of skills, and then on top you think you know that you gained all the skills, but you still don't know how things works. So how do I transform all this technology into running it into production? And there's oh shit, there's something wrong here. Sorry about that. Where is that thing going? Oops. There's something wrong with my screen here. Sorry about that. I have to put it in the other screen here. So you're on top of that thing. You think you know you gained all the skills, but you don't know, and then you're at this point where you realize you don't know what kind of skills you need to run that thing in production. And this is what I call technology noise. There's a lot of noise going on in the container ecosystem. There's a lot of things you have to consider. A lot of things still. It's still a premature technology. So there's a lot of things going on. How to use Docker in production and what are the right ways to do it. And you really need to go through that technology noise and eventually run Docker in production. And today I try to help you navigate that learning curve and don't trap in that technology noise, because I'm here to help you to avoid that and really kickstart your journey into microservice architecture and Docker technology. So let's start with a small refresh how containers are different from bare servers and VMs. So pay attention to this line. This is the time. So let us start with the old way to do it. So basically, for instance, you have this Ruby on Rails application, and then you want to run that in production. So you buy a server, install the OS and all the binary libraries you need, and then you run your application. So if you look at this red line, you see the time between development and production is pretty long. So the last 10 years, we evolved into using cloud, virtual machines, and platform as a service, where you easily could, drop in your code, provision a server in the cloud, and run your application. Now you can easily run a Rails application and, for instance, a Java application. And you see that the time between development and operations decreases, and now with containers, decreasing more in time. So now you can, put everything together in this containers in this image, which is the base of running your container, and your OS is isolated, your binaries, your libraries are isolated, and you can really be portable with your code and run that in different containers. And if you pay attention to this graph, what you're seeing is that moving from a server, provisioning a server, to provisioning containers and using your application in containers, you see that the development and the operation sides is getting closer. And this is really interesting. So the gap is closing. So dev and ops need to work together with containers. And basically what we're going to see in this presentation, you see that a lot of things, operational side, is moving into the hands of the developer, and the developer needs help with the operations. So that's a quite interesting thing to note. So if you think the heart of your minimal viable product is your service, what I call the minimal lovable service here, That's the service your team nurture and bringing and being proud of. And of course, if you're using containers and microservice architecture, this love can be, simple at first sight. So you start with a simple service and can quickly turn into something complex. And that's also why it's important to really pay attention to this technology noise. Because if you go down the path of microservice architecture and container technology, make sure you don't get lost in all this noise which is running around in this container ecosystem. So creating your minimal lovable service without dying premature starts basically with the base of all your service running in containers, and what I call the minimal lovable image. Without the right image, you can't run Docker in production. I probably will repeat it a lot of times in my talk, that before you can run Docker in production, you need the right image. So let us explore what's inside that image, the base of your containers, and get that image right. So when using Docker, you need an image for your service running inside the container. So this is a process I call the containerization machine of containerization. So you drop in all your code, the libraries and dependencies using a Docker file, if you're using Docker. And you're creating this new service and push out these nicely created images. And the key to successfully run Docker in production is to optimize this containerization machine. So Docker is not a silver bullet. It won't solve bad design or choices when you're a developer. So if you throw in some shit in your containerization process, some code which is vulnerable or even secrets dangling around in your image, you end up with a shitty image for your service running in containers in production. So we really don't want that. So we really want to take good care of your image, because you can't polish a third. Also not with Docker. It's not a silver bullet. So if we look at this minimal lovable image, your image should be the same in your development environment, test environment, staging environment, and production environment. And what we're going to look at is it should be small, secure, performant, stable, and immutable. So let us explore how to get the right image and dive into all those steps. So let's start with small. So what do I mean with a small image? Basically the smallest possible footprint which is needed to run your microservice at runtime. So why is this important? Of course, performance from your service point of view, but also your deployment point of view. Because if your image is really big, it takes a lot of time to push that out to your servers. And also reduce security risks. Know all the things inside out of your image. Well, from a developer's point of view, you feel like a system administrator again here, because you're really building the whole system where you run your coding. So how are we going to do that? So the first thing you have to do is start, when building an image, start with the smallest basic image you can find. And make sure you choose a trusted source, that you know exactly which steps are done to create this image. Also, remove the compile time dependencies you don't need during runtime. And also remove the packages you don't need. Because in the end, it has to be like a small contained image. And also squashing the image in the end. It's like removing the layers of your image you don't need. And also remove the secrets and all that stuff. And also, which is important, is to run statistics to show all the image layers for further inspection. And also to find out how to bring the size even more down. As you know, an image is built of layers, and those layers can change, and you can really look at those layers if there are things you have to change. Also, the right image should be secure. So what is a secure image? So basically, the Docker engine where your container is running already has a sandbox where it's running in. It's already with namespace and all that things, it's already isolated. But it's also important to make sure that your image from the start is already secure. And it is of course important that you're not leaving any backdoors open, and also that you don't have vulnerabilities in your code or running packages which are vulnerable to attacks. So how are we going to do that? So make sure in the beginning that you remove all the secrets from your image. So if you are using a private key to pull some code inside your image, make sure you remove that private key. Because if a hacker breaks into your service, it can pick up all that code. So make sure that you remove all those things. And also patch your image. So if you are using a base image, also make sure that it has the latest security updates. And also the process you run inside your container has a right user ID. So don't run everything against a root user ID. And also test the image. Test your image for well-known security issues. Make sure that part of your containerization machine involves testing the security of your image. The right image should also be performant. This is also the place where I think the developers and operation people should work together. This is where so what is this performant image? Well, when you're deploying a service using a performant image, you know exactly how the performance against a certain load and how much memory it will consume and so on. So this is really defining what your service running in this container can do. Why is this important? So you really have to take care for the performant image, because you really need to know what kind of infrastructure and capacity you need if you want to scale. So it makes the operation side of running containers in production much easier. How are we going to do that? So start with optimizing your code. Well, as a developer, you're already aware of optimizing your code. But in containers, you're also in charge when creating an image of the operation side of your code. So for instance, you have to tweak the process to support enough concurrent connections, or make sure that there's a cap on the memory. So running tests and see how much memory and CPU your container is using under stress makes you aware if your service is performant and what it needs when you want to scale. Also, to make your life easier, only run one process in the container using your image. What I see a lot, also if I look at our customers running Docker in production, what you see a lot is that they using images which do a lot. So it's running like maybe several processes in one container, and that makes also scaling much difficult. So it's better to just run one process in one container. And also, again, testing is important here. So do some load and performance testing and make it part of your automated test plan. And also because you will benefit a lot in production using a performant image again. Also, the right image is also a stable image. So what do I mean with a stable image? It's an image which you can rebuild over and over time without breaking. And why is this important? Because what you want to make sure, if you distribute your source code and sharing that with your co-workers, using Git and containing a Docker file and all the things you need to generate your images, the Docker file is the recipe of your image, right? So it has to behave the same way. So if I build the image on my computer, on my co-worker computer, or somewhere else in the test environment, it has to behave the same way. Of course, you can create the image and then ship the binary of the image, but sometimes it's good to have the Docker file also be in place to create a stable image. So how are we going to do that? So if you create an image which is stable, lock the image version. So when you're building from a base image, lock the image version and tag name. So don't use the latest tag, because you don't know when that image changes over time. And also, if you are going to pull an image from a source you don't trust, it's really dangerous when you're pulling the latest image, because they can inject that image with some vulnerable code. So make sure that also, I mean, it's not that it's guaranteed that you pulling in some vulnerable code, you still have to check that, which I said a couple of slides back. But the thing is that you have to log the image version, that you make sure you always run against the same version. And also if you have you need a runtime version of your code, make sure that you log that in, so a specific Ruby version or something like that. And also check your generated image. So if your image is generated, check that generated image, because everybody can then check the corresponding code and Docker file for testing and debugging. And also make your logging the same for every service you are using. So this is also the time where it's good to have like a team guidelines how to create images, and also make logging uniform so that it's easier for you for testing and debugging. And also that makes your image more stable. And the last bit where I want to talk about the right image is immutable. So what is an immutable image? Well, there's two sides of an immutable image basically. It's what I see is an image which doesn't change at runtime and don't know about your infrastructure looks like. So it will run in all your environments from test all the way to production. Why do we want this? Because we want to run this image in test development, and we know how to behave it on different systems all the way to production. So how do we achieve that? This is not really the steps you take, but it's more like when you're thinking of designing your image, probably the things you should do or don't do. So the thing I see a lot when people are trying to, running Docker on their computer with Docker Compose to compose all these images, they get really overexcited with volumes and linking containers and all that stuff. And that makes your architecture pretty coupled there. So, but you want to achieve, and that's also a little bit, maybe it's immutable is not the right word for this one, maybe it's loosely coupled, but you really want to go for loosely coupled. So for instance, don't use database inside an image. For development purposes, it's okay, but in production it won't scale, because you have to take care of a lot of things like volumes and backups, and when this database goes down in your container, how do you auto-heal that and all that stuff. So please use external services persistency and don't abuse the host system. So that is important to know. So there you have it. So a nice image you can work with. And if you create this minimal lovable image which is small, secure, performant, stable, and immutable, then you have the right base to run that thing in production. So from a development point of view, testing, staging and production, you have the base ingredient to succeed running Docker in production. So let's get to step 2 of phase 2 of this presentation. How the hell do I run Docker in production and will it scale? So I will talk about the 7 things you need to consider running your minimal lovable image in production. So let us start with what I called the DevOps design flow. You really need something in place which from the development till production is all steps you need to consider. So one thing which is really important is mimic the environment. So a lot of our customers and myself are using Docker Compose, which is this way to compose your service on your local machine to test the whole environment. So it's really important that before you run in production, you can mimic the same environment on your local machine, but mimic the same environment also on the test environment, so that you really can move your image and your code to all stages in your process, all the way from development to test to stage to production. So you really mimic that environment, and that's also what I'm talking about, that immutable thing, is that it's really important to loosely couple that, to make sure that it behaves the same. As a team, it's good to have like these image guidelines this base image if you're using Java, use this base image if you're using Ruby. So it's good to have this whole tool set of base images which are, for your purposes, already trusted. You can also make use of image building tools like Habitus. I will talk about that later on. And also test heavily. So basically streamline the process that it can run in your development environment, but also in your continuous integration and continuous deployment tools and architecture. Another thing which is to consider is orchestration. So orchestration is kind of a vague term basically, because sometimes orchestration is about, you know, building your infrastructure, spinning up your servers, and you know, installing things. But for me, orchestration is also about the operation side of your container. It's about the isolation of services. What I mean by that is that so you can run Docker in production on a couple of ways. One thing to do is just, you know, create this big cluster of Docker hosts, and then just, you know, run all those images on those different clusters, and then just go for it. But the thing is that sometimes you also want some isolation of your services. You want to, you know, have maybe running a Docker cluster only specific for that service and services, and then run the other things which are nothing to do with the other service, run in isolation. Also, orchestration is also about making use of the resources available. So you really need to know in your platform where the resources are, and then run that image on that place. So you know when you scale that you're not running out of resources. Also, self-healing is also part of orchestration. For instance, if a service goes down, will some service running on another server picking it up, and is there something in place which can, you know, distribute that load to the healthy services. So load distribution is also really important to have that in production. So all these things what I'm talking about, like orchestration and other things I will talk about later, they're not part of just, you know, creating an image and run the Docker. You really need to, you know, find all that service for you. Also, orchestration is adding nodes to your cluster. Discovery. So discovery is about finding your services. So for instance, if I deploy my web application in Docker, and I have an API and I have static pages, and I have a database and maybe some workers running around, they really need to find each other. And but as a developer, you don't want to, you know, change your code. So you want a minimal code change, and by doing that, what we're seeing is that, and also what we are using is that we're using like DNS-based discovery. So you can say, I want to talk to the API. What's the IP address of the API? And then the discovery service gives you that API. So it's really important to have a good discovery service. Also, versioning of your running service is important. For instance, if I'm running an API and I make some code changes and the tests are green and this API is deployed to my Docker cluster, then my system has to check if the new API is up and running, and then I have to switch between API version 1 and API version 2 and make sure that all the clients are redirected to the right API. So there is a lot of intelligence needed to do all the versioning of the running services, which is part of the discovery. So if people are talking about discovery and Docker, running Docker in containers, they're talking about finding your service, but also versioning of running services, and also automatically update discovery when new servers are online or scaled up and down. For instance, if I'm running an API service on my Docker cluster and I find out that I need more capacity because there are more customers using that API, then I can say, okay, just run like 10 containers with this API image, or maybe 100 containers with this API image. Then the discovery mechanism needs to make sure that all the traffic from the front end is distributed to the right images. So I see that a typo there. So scaling. So if you run Docker in production, you need to scale. So depending on your load. So you have to scale your containers. That's what we're already talking about with the discovery. So when there's load coming in, you can scale your containers, but also scale your Docker cluster. So basically, scaling your containers, what I called micro-scaling or whatever you call it, but it's just, you know, run an extra container using that image. But then probably you're going to run out of resources of this cluster, of this server, so you have to scale up your Docker cluster, which is also important when you run Docker in production. And also, because you're running a couple of servers, all the discovery protocols is also important. And also scale your on and off jobs, so jobs you're running a couple of times, or maybe more. And to be resilient and scale, you also need something like failover groups. What's happening when you're running Docker in production on one data center and that data center has an outage? What are you going to do? So you have to, you know, diverse that traffic to another part of your system. So that's also important things to reconsider if you want to run Docker in production. There's the same thing with cross-cloud clusters. So you can run maybe your service on AWS and also a part of your service running on DigitalOcean and let them work together, and then you make your service more high available. And also load balancing. So if traffic is coming in from your website, how does the load balance to the different services? So that's all things you have to reconsider running Docker in production. Data management. So data management, that's also of course important, and so we at Cloud66, we are not going for running your database inside the container, because databases are already here for like 20 years. Like MySQL is created 20 years ago. They really know how to run that on a server and how to scale it across different services. So, and also it's really hard when you run your database in a container to scale it up, and how do you make sure your data is consistent. There are solutions to, you know, distribute your volume across your cluster, but it's still early days to make that production ready. So for data management, if you're running like database, make sure that you can back up and restore your data, which is trivial of course, clustering, and also verify your backup. And another thing which is important is doing, and things you need to reconsider, is monitoring. So you really want to get all the statistics of your resources, the memory, the load, how your network is doing, and how many resources it's using, and also combining of all the logs, so that you have one place where you can go to from a user interface or a command line interface, and you can say, okay, just give me all the logs of my images running in my cluster. Because logging is really important also, part of the monitoring, because that's one of the things you need for debugging your containers if they're running in production. Security. So all the things which you need to reconsider running Docker in production. There's a lot of things which are already, you know, trivial to you, because it's, I mean, if you're running a web application, you're already talking about security and firewalling. But it's still, I repeat this because it's also important that you know that if you run Docker in production, you still need all those things in place, like intrusion detection and prevention systems, but also denial of service protection. If people are going to try to take your service down, are you protected for that? Also firewalling, so make sure that, and also inter-firewalling between services. So which services can be talking to each other. It's not really firewalling, but making rules in your network. This service can only talk to service A or B, or can talk to the outside world. And also if you want to run your infrastructure on your virtual private cloud, you need something support for bastion servers or gateway servers. And also, but when you're using security, I was already talking about when creating the right image is also the verification of the images. Not only the images you are going to pull, which probably are trusted from your coworkers, but also the base images. So you really want to make sure when you run Docker in production that the image you are going to use to start that container is secure and doesn't do things it doesn't allow to do you on your cluster. Because you are, and especially in this time where you can really mix and match different technologies, open source, closed source, you make sure that things are secure and that you can sandbox them if needed. So to answer the question and summarize my presentation for today, so how the hell do I run Docker in production and will it scale? So basically, start with getting the image right with your team. So really start small and smart with your images and running Docker in production and scale up later. And create the image you love. So the image you love, and also it has to be small, secure, performant, stable, and immutable, which makes scaling a breeze later on. And again, running Docker is not a silver bullet again. So you really need to know that first part, creating that image. If you have image right, you're halfway running Docker in production. And also, if you want to run Docker in production, reconsider all the parts you need to running that, and choose the right platform. I mean, Cloud 66 has a great one, but there are other ones you can choose from, or build your own if you have the capacity. But keep in mind that Docker is just one puzzle of running container and your microservices in production. And don't forget, people love good service and use containers wisely, and don't get trapped in the technology noise. So figure for yourself out what kind of ingredients I need to run Docker in production and start with your image. So at the end of this presentation, I want to thank eSynergy for the opportunity to give my talk on this webinar. And so you can find more about running Docker in production reading our blog. And I was talking about when creating your image, you need like this Docker build flow. And we created an open source tool called Habitus, where you can step by step compile your code, get your binary out of your image, put it in a new image, extract and squash the image so that you don't leave your secrets tingle around and stuff like that. So Habitus is like the Docker flow tool will make creating those lovable images much easier. Also, we have this open source project called startwithdocker.com, which is this project which you can run against your code and will spit out like a Docker file and a Docker Compose file where you can start developing your project with Docker and run that in production. And also you can of course sign up to run Docker in production with Cloud 66. If you go to this URL, you can sign up and you can try us out. If you want to extend your trial, if you want to have more time, just reach out to me. I can extend your trial and I'm happy to help you run Docker in production. So thank you. So let me see if there are any questions. So this is one question by Mohan Pawar. He's asking, how about adding storage backend, create dependencies, and how it affects performance of containers? Yes, that's a good question. So I can imagine when you are, for instance, running a web application and you want to save like uploaded files to your host file host system. So because it's Docker is using like this layer system and almost have directly access to the host system. It's quite fast. And so we are also using cluster FS as a network attached storage solution. And of course there are some lag there, but it's almost real time. So there is of course a performance loss there instead of directly writing to your storage, but it's also important to test that in production and see if it does your requirements. Okay. Another question by Vivian King. So, how does one verify these images? Is there an automated way of verifying the images being used in your Docker container? So right now, what you see is that they're still in the last Docker release, I believe 1.11. They have support for that you can sign your images. So basically, when you build your image on your local machine, you can sign it with your private key, and then running that image in production, you can of course test if that thing is signed by the right user. So basically, you sign your image, then deploy it, and then on the Docker cluster, it has to check if it's verified. I believe that Docker Hub is also doing that, and so there's still a lot of things going on to get that thing up and running in production. Also, this is a question by Louis Cesar. He's asking, is it correct to use Docker Machine and Docker Compose to run Docker in production? Good question. So, there are different ways to run Docker in production. If you're going to for Docker Machine and Docker Compose, that's a way to do it. But the thing is, what are you going to do when you scale up? Because with Docker Machine and Docker Compose, you don't get things like databases. So what about databases? What about monitoring? How do you combine all those log files? I mean, there's a lot of things which you need to reconsider. Another question by Moa again. He says, kindly tell your views on root of container and root of host. Yeah, so basically that's the same thing when you're running a web application. You don't want to run your web application as root. So depending on what you're going to achieve, it's better to use user IDs which you share between the host and your container, so you make sure that they're the same user ID. But don't use root. Only use root if you do something which involves talking to the Docker to the Docker engine, and if you do that, make sure that it's not accessible from the internet. So you don't want to, a hacker hacks your service and then has root access to your host. Another question by Vivian King. What is the best way to publish logs using Docker in production? Is it a good use of volumes? So basically, Docker already, all the logs from the standard log are going into this JSON format to your host machine. And what you can do is that you can install a monitoring or logging aggregator which will pull that JSON files from the Docker engine and pull it somewhere else. So for instance, we're using Telegraph to monitor all the logs and all the resources used and pull all that information to the database. So basically Docker is already using a volume to save your logs on the disk, and then you can tap into that. Let me see if there are more questions. I think we're running out of questions here. So if there are any questions, please let me know. So there are no more questions right now, so I want to thank you all for watching this webcast. So check our blog posts, check our habitus and starter, and if you want to run Docker in production, please sign up with Cloud66 and reach out to me if you need further assistance. So thank you for watching today. My name is Daniel Gils, developer advocate at Cloud66.